Gonna count me in or I go? Yeah. I go now. All right. Hey everyone, how are you? My name's Ismael. I'm one of the co-founders of Lagrange Labs. So Lagrange is a company that focuses on zero-knowledge proofs, and particularly zero-knowledge proofs at the intersection with AI. So we build a variety of technology that's heavily applicable both within crypto and outside of crypto that purposes zero-knowledge proofs for applications using machine learning and AI in security-critical sectors. So what's a security-critical sector, right? You can think of anything on chain that controls or touches crypto assets as a result of the use of AI. You can think of defense, aerospace, right? Any type of autonomous system that makes a kill chain decision independent of human intervention is an autonomous system that's in an incredibly security-critical context. You can think of things in healthcare, things in medicine, anything that touches patient or client data, things in TradFi, things in financial services. So the use of AI is becoming increasingly prevalent across a variety of verticals, both within crypto and outside of crypto. And the trust quotient that we are forced to maintain with these systems is increasing as well. There is effectively a large number of opaque systems that operate as black boxes, where the model that operates within these systems is not something that is demonstrably correct. We do not know the correct models being used. There's no assurances of privacy of the input to them. And we're predicating increasing amounts of economic value on top of systems that are very hard for us to interpret any type of reasoning around. And so this is where zero-knowledge proofs become incredibly relevant, right? It's a technology that we've effectively financed in crypto. It's about $1 billion in aggregate private capital has moved into R&D for zero-knowledge proof systems over the last 4 years, right? You can think of all the great companies from Starkware, Aztec, zkSync, et cetera, that have effectively pioneered the application of these for the sale of zk-proven block space, right? L2, zk rollups. But the demand space for trust, safety, and privacy on top of high-value computation is substantially larger than simply the sale of L2 block space on Ethereum, which is a very niche market. The reality is the amount of economic value that we predicate in modern society on top of AI outputs is far higher than the aggregate TVL of a couple of L2s. And this is where zero-knowledge proofs very broadly find what we believe is their killer application, which is adding trust, safety, and privacy onto AI used in security-critical sectors agnostic of industry. And so if we think super intelligent systems are inevitable and that every company is going to leverage AI as part of its core business process, how do we ensure that this aligns with a set of values or a set of security properties that we deem to be acceptable? The current set of modalities that are available don't really address this. And so this is where zero-knowledge proofs are effectively singular in their capacity to assure that AI systems operate correctly, right? I like to give this example that there are very few technologies in any industry that are directionally correct, right? We don't know with very much of a guarantee if proof of stake or proof of work or a consensus mechanism of any type is going to be used in an increasing prevalence in 10 years as it is today. We don't really know, whether or not crypto assets and stable coins in their current form or tokenized stocks on chain will necessarily be used in a greater degree than they are today. But there's very few technologies across any industry that we can say with near certainty are going to be used in a higher frequency in a decade than they are today, right? Things like AI, things like quantum computing, things like asteroid mining, like just far-fetched ideas, CRISPR in biotech. Zero-knowledge proofs are one of the few things in crypto that we can say if we were to re-architect all security systems with advanced cryptography, which is what zero-knowledge proofs effectively are, the technology would have increasing demand the more performant it gets. And effectively, it's one of the few things developed in crypto that is unambiguously directionally correct. And so AI being another technology, the intersection of these two effectively is one of the few opportunities to pursue two things in parallel that both are directionally correct. So if you can't trust something, you should verify it is an axiom that people often say in crypto. And it's increasingly relevant both outside of crypto as well. So zero-knowledge machine learning is a research area at the combination of two very exciting research areas, zero-knowledge proof research and machine learning. So zkML combines ZKPs with machine learning and allows computation from an ML model to be proved. At the simplest form, that's proving computation or inference over some private input. At the more complicated level, that is things like fine-tuning, interpretability, explainability, training, et cetera. And so Lagrange builds a library called DeepProve. DeepProve is the fastest ZK machine learning library in the space by a very wide margin, about 1,000x faster than our closest competitor. It's a revolutionary framework that is built on a bunch of core cryptography from our research team, based on a number of papers that we've authored with great IP assigned to the business. That is, we think, one of the few technologies in crypto that's actually broadly applicable outside of it. So how does DeepProve work? So first you take an arbitrary ML model, you take an Onyx file from that model, a representation of the model architecture, the weights, the biases, et cetera. You put that into a compiler effectively, which parses the model into a bunch of modules. We're able to generate circuits from those modules, and then upon request, we can generate a proof of the inference from that model. And then that inference can be verified anywhere. So you're thinking of fleet management in a defense context. You can think of assurances over the correctness of a diagnostic model in a healthcare context, or a trading bot or an on-chain agent or agentic finance, like everyone likes to talk about now, being another very natural application of that, right? It effectively takes zero-knowledge proofs and it allows you to assure guarantees of correctness over AI. And so the library we build, DeepProve, is substantially faster than baseline and state-of-the-art solutions, about 1,000x on generation and 1,100x on verification. That's only getting faster. A very interesting metric is that the larger the models become, the more performant our proof generation becomes. So if you're talking about like a frontier model, 300 billion parameters, we're actually proportionately faster than our comparables than the baseline. So effectively, the larger the model architecture is, the faster we become because of the parallelism and the natural performance properties of our proof system. And so, we've talked about the tech. Why does this matter? If we're using AI everywhere, healthcare, defense, medicine, finance, we need guarantees of correctness and privacy over the underlying input, right? It's very, very hard to build fault-tolerant systems that don't have cryptographic guarantees of correctness. The entire internet today is based on TLS on top of HTTP, effectively cryptography that secures e-commerce, online banking, digital payments. Everything in the modern internet that we're familiar with predicates itself on security derived from cryptography. But the modern architectures of these cryptography are not sufficient to directly address the problem space of adding cryptographic guarantees on AI. So the comp I like to give is that effectively what TLS has done for internet security, ZK is positioned to do for AI security. It's a massive, massive market effectively. And so why trust us, and why are we some great solution? And why are we better than literally everyone else who's talking about verifiable AI? Because you don't have to trust some hacked together blockchain architecture that a lot of people here are trying to pitch and a lot of verifiable AI companies are talking about. There's no consensus or some made up economic weighted TE environment. It's just mathematics, right? There's effectively formal proofs of the correctness of the models that are highly applicable in settings outside of crypto where people don't even want to talk about staking of tokens. And it's also highly applicable in crypto. You can just go look online, you can go look at the libraries, you can go look at circuits, it's all public. And mathematically, we're able to guarantee things. Not on trust us, not on trust to stake, not on trust the consensus, just on pure math. And so how have we been able to do this? We have a very, very large research team. So our chief scientist, Babis Papamonthu, is one of the co-directors of the cryptography lab at Yale and a professor there. We have a team of 7 PhD researchers in applied cryptography and computer science with over 22,000 combined citations in computer science and applied cryptography. One of them is actually sitting right there. And we've authored a number of papers over the last few years from Lagrange. Actually, if anyone here is familiar with Stanford Blockchain Conference, one of the top academic conferences in crypto, we've placed papers 2 out of the last 3 years there. And here's just some sample work from our team. And so, this is already being adopted by very, very large AI companies. We work with Intel, NVIDIA, and a bunch of other very big Web 2 AI companies. We also work with a lot of AI x crypto companies. All the major ones you can think of are partners of ours. We've announced with them. We're integrating Deep Proof into their stacks. Really everyone kind of in crypto right now and outside of crypto is trying to address trust and safety issues with AI. And there's really not a more natural fit than ZK. And now real world use cases, right? Like why are people using this stuff? You can think of like the unimaginative use cases, which is like all of the made up agentic stuff people are doing in crypto today to launch tokens, which is like, oh, we're gonna have this like yield aggregator bot and this trading bot on chain. And that stuff's great, right? I love that stuff. But like, that's a great use case. You have $100 million in an asset on chain that's sitting in a vault and it's controlled by an LLM. Probably you should make sure that the LLM is correct, right? If you have a yield aggregator that's doing a funding rate trade, it's buying spot and shorting on perps or something, and it's supposed to allocate its assets based on some regression model. Well, you should probably make sure the regression model is running correctly so it doesn't just rug all the assets in the basis trade. And yeah, so that's kind of the unimaginative use cases. The ones that we see the most demand in are things actually outside of crypto. So you can think of aerospace defense, so the use of autonomous systems that are used in security-heavy contexts, fleet management for drones. All of this is generally decentralized architectures by default and are highly untrusted settings. And so assurances of security and fleet management is actually very important. Healthcare is another place that we've seen massive adoption of this stuff. There's major hospital systems already using this. Diagnostic models, for example, are very compliance sensitive. The weights of those models are very heavily compliance sensitive. And then there's some stuff with like deep fakes and content moderation. So I mentioned agentic systems being a highly relevant use case. You can think of, killer robots if you're really being pessimistic about it, and you can think of like, autonomous vehicles in warfare as kind of a place where you would like assurances that the AI that's being used to make kill chain relevant decisions is operating correctly. Otherwise, the outcomes could be severe. Financing compliance is a big one. We see actually banks adopting this stuff. If you're using agents over customer data, there's obviously compliance requirements over access to that. So it's not like a major bank can just go blast its data over to ChatGPT. So being able to conduct verifiable inference over private data is a massive use case we're seeing adoption for. Content moderation is a really good one that we've seen companies that are interested in. Like the entire of the modern internet is based on UGC content, user-generated content, and almost all the moderation from that follows the same design pattern, which is you upload content to a website, that website moderates it with AI, and then it'll display the content post-moderation. The problem is you have to replicate the moderation of UGC content, which adds a very, very high overhead on the cost of running a UGC-heavy website that has a large amount of content coming into it. What's actually very interesting is where you can have proofs that a content has already been moderated by a model embedded into the metadata of that image. So you can have front ends display content without having to remoderate it. So you can launch a website that effectively just says, if this thing has been already moderated on Facebook or Instagram or Twitter and has a proof of that, we're fine showing it. And that substantially decreases issues with illicit content or harmful content being shown. And then obviously IP management's a big one too. You can prove that something has been a derivative of a different IP and is an issue with some underlying law. And then DeFi, obviously, we're a crypto company. That's a very exciting use case that people like to talk about now. So like on-chain trading bots, we're gonna have a bajillion agents on chain. We're gonna have 1 million agents moving assets around, and they're all gonna have crypto as their bank account because you can't have a robot with a bank account. And if we have all that stuff, you effectively still need correctness. Otherwise, it's very, very hard to have these things be able to control assets if anyone can come in and impersonate the results of what they're trying to do. You effectively need to be able to say, this model says I should reallocate or alter this position, I should transfer some asset, and then you need to be able to verify that proof on the chain before the asset is transferred as a precondition. And we see a lot of people pursuing this with our tech. And then healthcare is one that I think a lot of people, at least myself, didn't think would be a massive use case for this originally. But we've seen substantial adoption. Diagnostic models, the weights of these models and the architectures as well are often considered PII if they're trained by a hospital system. And that makes it very hard for a hospital in Texas to effectively work with a hospital in Boston. Because you cannot have a diagnostic inference that results in you sharing a model between the two hospitals, because that would be paramount to sharing patient data. So what you effectively need is to be able to have a model kept private where the inference can be made verifiable, such that one hospital can have assurances that the other hospital is using the correct model while keeping that model private. So we've actually seen multiple partners actually building that with us. And so as a final kind of comment that I want to wrap up with, we're barreling forward into kind of a future economy that's heavily augmented by AI and intelligent systems. And the security of these AI and intelligent systems needs to be evolved to match the threat vectors that are being created as they're being used across different verticals. The same way cryptography has secured the modern internet, cryptography has to be used and will be used to secure how AI systems interact with each other. And zero-knowledge proofs are a technology that is developed in crypto. It was financed in crypto. It's a crypto technology, effectively. And it is the only thing that has the capacity to meaningfully add privacy and safety on top of AI right now. So it's a very exciting time for the space where we've actually are seeing something that's coming from crypto that's not just a stablecoin, being adopted by traditional sectors en masse. Anyway, thank you all for coming today. If you want to learn more about Lagrange, I'd suggest you go to our docs, you look at our tech. If you want to build something with us, please contact us. And yeah, thank you all so much.
Available as a generic thing you can do to any model, state-of-the-art model right now? And how can you ensure that the quantized model performs as well as the non-quantized model?
Good question. That's a good question. Yeah, so we support right now in the public version of the library simple MLPs, CNNs, and LLMs. And so, yes, you do have to quantize the model in the current version of the library, so you should obviously check the accuracy of the quantized model against that of the original model. I think the question of if quantized models have comparable accuracy is more of an ML research question than it is of a cryptography question. And you know, the process of quantizing models is something that is frequently done both within and outside of context of proving the model. Getting the model to run on you know, client-side devices, for example, requires quantization in a lot of contexts. There's some work that our team is actually doing over proving floating points more efficiently that I think might hopefully in the future remove the need for us to quantize models, depending on the performance of that. But we'll have to see. So right now, I'd say the answer is it would be the research questions surrounding quantization are ML research questions, not ZK research questions.
Where are you going with the product? Where are you heading with the product roadmap?
Where the money is.
Okay. And you're interested in enterprise use cases. I hear from the use cases.
Yeah,
so
if the money's green.
Great. Yeah,
I mean, look, I think that the crypto use cases are great. I love crypto use cases. A lot of our partners are in crypto. A lot of companies that are using AI in security relevant contexts are outside of crypto, right? Aerospace defense, healthcare, medicine. And so personally, we're very large fans of those sectors. I think the disturbing reality about the application of ZK in crypto is that it's a TAM that's shrinking, right? So the demand for L2 block space is growing less than an order of magnitude per year, right? There's fewer transactions. There's not 10 times more transactions on Ethereum L2s per year than there was the year before. But for the last 4 years, the performance of ZK systems have increased by an order of magnitude. So if your business is selling proofs, which is half this industry is, who's doing ZK, your TAM is shrinking annually into a heavy OpEx business. So it's really a bad sector to be in. So the question is either ZK was a miss and it's an academic technology and should never have been financed in the industry, or with the performance increases that we're getting, there are other places that it is relevant that have a much larger capacity to pay for the two properties that it sells, which is safety and privacy. In traditional enterprise contexts, and I'm including aerospace defense, healthcare kind of within that umbrella, like TradFi, Web2 contexts, are places where there are very high imperatives on privacy and safety. And so we think that that's the largest expansion area of Lagrange and ZK in general.
Thank you so much.
Thank you.